7:32, I think, right now.
Is there a guest speaker here?
Yeah, is our guest speaker?
Yes.
He
I'm
is.
here.
Fred's here with
One?
us.
Wonderful. Okay.
Except Fred is listed as Debbie Lusk for some reason.
It's because I'm having to use her computer because mine would not share screen.
Ah, okay.
All right. Okay. So anyway, I'll call a meeting.
There's Debbie.
Hi, Debbie. The hand from
Yeah.
outer space there.
All right. Can we get serious for just a few seconds here? Okay. Welcome everyone to the April meeting of the Stockton Astronomical Society. Not much going on that I know of. Tim is going to take the place of the vice president this evening and introduce our speaker, and he has a few announcements, or at least one, and I think a slide he mentioned. So Tim, why don't you go ahead and start, and we'll get the meeting going.
Okay, will do. Let me know when you see my announcement screen here.
It's up.
We got
Up.
So really, we just wanted to share with you folks the upcoming programs that the club has. Next month, we have the privilege of Nick Scott from NASA Ames, the research scientist, going to speak to us about exoplanets. If you remember, Nick Scott was the gentleman from NASA, correct me if I'm wrong, Doug, that did the presentation at Astronomy in the Park for the Apollo 11 anniversary. Coming up in June, our own Rebecca Lewis is going to share her research project. I'm not quite sure of exactly what the topic is, but she's going to speak to us about that project. So looking forward to Rebecca's presentation. In July, Dawn Mockholtz is talking to us about comet hunting. Dawn always puts on a great presentation. Looking forward to learning how to hunt comets. Nothing better than to find your own comet and get it named after you, right? In August, Pranvera Hyseni, our PhD student that Fred Schumacher knows, is going to speak to us about astronomy outreach in Kosovo. So that should be really interesting. And then I'm going to stop sharing for just a moment, and Eric's got an announcement that he's going to share with us now.
Hello, everybody. Let me try to get my screen back here. And let me try to share my screen. So an email went out from me to previous members of the old Yahoo Stockton Astro group. The old Yahoo group is no longer. Yahoo stopped support and services. So we have finally been able to convert all of our previous members over to a new group hosted by Google. So we have a new Stockton Astro Google group. And if you're not familiar with the group, the intent behind it is to notify club members of our plans for, like, when we go to Highway 4 or up to Peddler Hill, so that we can let everybody know who's going to be up there, what times people plan to leave and arrive, and what the weather is like, and most importantly, to, if you decide to cancel, you're not going to go up there, to let everybody know, so you don't wind up there all by yourself. But if you're not a member and wish to become a member, you can send me an email and I'll add you to the new group. But let me just go ahead and share my screen here. Let me see how to do it. Where is sharing? Share screen. Can everybody see something that resembles
Yes, we can.
Stockton group? Okay. So can you see my mouse moving?
Yes.
Okay. So right here, this top link here, it's not really a link, it's just an email address. You can send messages to the group by way of email, and that's the email address. Or if you don't want to send messages by email, you can, from any computer or tablet or iPhone or Android phone, you can come to our webpage here. This is the link for the webpage, groups.google.com/G/Stockton Astro. And you can post messages directly online here if you want. You can come up top left as new conversation. You can start a new conversation there, and you can I can probably see a little bit more than you guys might be able to see because I'm a administrator of the group, but there's a list of conversations here. You can open them up, and I can click on the first one, for example, and you can see what has been going through the email to other members. And if you wanted to reply down the bottom down here, there's a reply all or reply to author, or you can forward the message on, and it's basically just acts like email if you log in directly as well. So yeah, you have both of those options. And that's basically it. If you're not a member and want to, again, hit me up on email or call me and I'll add you. All I need to know is your email address and you'll start to receive the messages. Any questions? I guess not.
Excellent. Thank you, Eric.
You're welcome.
I'm going to go back to my screen. And if we're ready to for our program this evening, I'll do the introduction here. Okay. So I have the pleasure this evening of introducing Fred Lusk, who is a good friend of mine. I met in the engineering world, and it's always great when you find a fellow astronomer that you discover and you instantly have a kindred relationship and you have instant friendship and things to talk about. So that's the way it's been for Fred and I, and I've really enjoyed this. Fred is a professional consulting engineer by day and active astronomer by night. He served on the board of the Central Valley Astronomers, that's the Fresno Club, since 2001, including 4 years as a club president. For the years 03 to 18, Fred published a wonderful wall calendar. I could share some samples of that calendar. I bought 3 years, I think, from Fred. He was the first person in the Central Valley Astronomers history to observe Omega Centauri and from the Fresno area using, get this, a 5-inch telescope and 10 by 50 binoculars. And the only one to observe asteroid 163 Hilda, and he has observed the hexagon on Saturn's North Pole. That's quite an observation. And he's seen Andromeda's brightest globular cluster, Male 2, and a triple shadow transit on Jupiter. That must have been exciting, Fred. Fred enjoys everything from solo observing to large public sidewalk astronomy events. I know he loves public astronomy because I was at the 2019 Glacier Point Star Party that he invited the Stockton Club to, and many of us joined him there with the Fresno Club. And Fred gave an excellent presentation to, oh gosh, there was about 200 people in the audience Friday and Saturday night. And Fred gave an engaging introduction to astronomy and then had folks around his telescope all evening long. We really enjoyed that, Fred. We had a great time. And we hope to go back with you all to the Glacier Point Star Party in Yosemite Park sometime soon. Fred's going to speak to us tonight on a topic he calls Galaxy Quest. And I won't spoil it by giving you any more information. I will, though, share one more slide or two. This was the Glacier Point Star Party. You can see many of us from the Stockton Club were represented here. There's Mike and Susie with their backs to us, and Fred, Mike, and Sean, Tom Palmer there in the background. We had a great time. And then I wanted to share this kind of cool astrophotography that Fred did back in 2015. So Fred, you can probably tell us a little bit more about this, but I just think this is the coolest star trails photograph I have seen. And I'm just amazed, and I really enjoy it. So I wanted to share it with you before we get started with Fred's presentation.
Well, let me explain. My wife and I had gone up to Yosemite for the day. We go a lot. I've probably been to Yosemite about 200 times in my life. It's my favorite hangout place. So we decided to go up and just kind of hang out for the evening. And so I decided to do a star trail. And I was a little bit constrained because I was having battery issues and it started to get foggy. So you can see the clouds coming in. So I set up, I was hoping to do about a 3-hour star trail. I ended up doing, I think about 45 minutes was about all I could get. But what's interesting about this is as the humidity was increasing and the fog was coming in, it made the star streaks get wider. So they start off closer to pinpoints and end up being wider. But it was really kind of a cool thing. And I was actually controlling my my camera with my iPhone, using it as the intervalometer. And the battery problem I was having was my iPhone. This was not long before I replaced it. Let's put it that way, because the battery was done for. But I love doing star trails. It's one of the easiest forms of astrophotography. For years, I did it on film, up to probably about 3-4 years ago. And I've now switched totally to digital. In fact, my current Olympus digital cameras have what's called the live composite feature, which actually will blend exposures up to 6 hours total duration to make star trails. And I've also added a circular fisheye so I can do all sky star trails. And at some point, I'll send Tim a few examples that he can share if he wants to. So,
excellent. Well, Fred, we look forward to your presentation tonight. Let's put our hands together and welcome Fred Lusk.
All right. Well, thank you. Let me get over to the screen. So does everybody see a picture of M101?
Yeah.
Okay, that means we must be good to go.
I don't see it.
You don't see it. Does nobody see it yet?
I do not see it.
Okay, well, let me go back and try this again.
Here we
We're on
go.
our way now.
Okay, I must not have pushed the share button hard enough. Okay, so should see everybody see a picture of M101?
We do.
Yeah. All right, good. So now we can start. So tonight we're going to go on a galaxy quest. And not so much the movie, even though it's one of my favorites, but I thought I'd throw in a few Galaxy Quest pictures. That was actually my inspiration for doing this presentation. And by way of introduction, it's important to talk about the history and significance of galaxies to our understanding of the universe. Galaxies have been seen since antiquity, but they were not known until the 20th century. And that's the important point, because up until the 20th century, we had a very tiny view of the universe. But the ancients, especially in the southern hemisphere, saw galaxies. Obviously, everybody's seen the Milky Way. That's obvious to anybody on Earth if they're paying attention. But in the southern hemisphere, you have the large and small Magellanic Clouds. And the Australian Aborigines, for example, noted those galaxies a long time ago, and they're actually in petroglyphs and pictographs that the Aborigines have drawn, and other societies have known of these. And of course, in the northern hemisphere, M31 Andromeda should have been obvious to anyone who was paying attention, because I've even seen it after midnight in suburban skies. And if you go out into a dark sky site, it's obvious if you're paying attention. M33 is also visible under good conditions to somebody with average to better than average eyes. I've actually done it from the valley floor after a good rain with a follow-up cold front, and I've seen it from the mountains numerous times. It's not very distinct, but you can tell that it's there. So galaxies have been seen since antiquity, just not known. So the first report of an exterior galaxy, even though they weren't known at the time, that we're aware of was written by Abdul Rahman al-Sufi, who was a Persian astronomer, astrologer, dog catcher, chef, who knows what all jobs he had, but he was a smart guy. And he wrote a book called The Fixed Stars, and in his diagram of what we would call Andromeda, the constellations there are a little bit different. That little fuzzy patch at the end of the arrow is where Andromeda should be. And that's the first known report of it, even though probably it was known before the mid-900s. Another point is we discovered our own galaxy only when we discovered other galaxies. Before the discovery of exterior galaxies, most astronomers thought that the Milky Way was it. And they thought that these exterior fuzzy patches were just part of our galaxy. And so the discovery of galaxies also increased the size of our universe in our perception. Of course, the universe has always been the same size that it is, but we didn't understand it, and we didn't have a good view of the size of our universe. Then there's also the beauty of galaxies. It's not just the science, but first of all, spring is galaxy season. This is the time when people go out to hunt galaxies because the largest group of bright galaxies that we can see is visible to us in the spring. Galaxies are fun and challenging objects to observe and to photograph if that's your thing. But there's also more to galaxies than meets the eye, which we'll get into a little bit later. So tonight, the outline, we're going to look at the discovery of galaxies, and we're going to start with a brief introduction to ancient cosmology, which I'll explain that picture here in a second. The slow shift in thinking away from ancient to modern cosmology, the discovery of other galaxies, and the simultaneous discovery of our own galaxy. Now, the picture on the right is part of the story of Turtles All the Way Down. Some of you may have heard the story. There are multiple variations of it. The short version is that some really smart astronomer is giving a public talk, and at the end of the talk, some little old lady comes up and says, "You may think you're so smart, but," and then she goes on to say that I don't believe this idea of, or I don't believe everything you said. I believe the Earth is flat and it sits on the back of a turtle, all this kind of stuff, which actually was an ancient view of cosmology. And he said, "Well, what's below that turtle?" Another turtle. "What's below that turtle?" Another turtle. "What's below that?" It's turtles all the way down. And so that's kind of become a catchphrase for strange thinking, let's put it that way. But anyway, just remember, it is turtles all the way down. Then when we get to galaxies, we're going to take just a brief look at galaxy groups and clusters, including the local group, the Virgo cluster. This picture here has some of the brighter galaxies in the Virgo cluster. We're going to look at a couple of interesting galaxies. We're going to look at a couple interacting galaxies, talk about those a little bit. This is the mice down here. They don't look like mice, but that's what astronomers have called them. And then a few observing challenges related to galaxies. So we appear to be at the center of a bright Milky ring, so we must be at the center of the universe, right? So that's the view that the ancients had. They could look up in the sky and see this big ring that changed, month by month, its orientation, but it was bright and cloudy. And because we see the ring all around us, we must be at the middle of the ring. That was the thought when they didn't have means to actually study this. Here's a little bit bigger view. These are pictures by Axel Mellinger. They're some of the best all-sky views that I've seen. And imagine wrapping this around you, and that's the view that we would see if we had nice cameras and telescopes, which the ancients obviously did not have. So seen from antiquity, the Milky Way, as I mentioned, the large and small Magellanic Clouds, as I mentioned, Andromeda, as I mentioned, possibly M33. And then there are reports in modern times of very sharp-eyed people being able to see M81, NGC 5128, M83, NGC 253. They are far beyond my ability to see, but apparently some people have seen these, measured probably in dozens at best. And so if anybody was a long time ago really paying attention to the sky, they would have seen a few more galaxies than just the Milky Way and the large and small Magellanic Cloud. I need telescopes for all those. So here are some of the ancient ideas about cosmology. And you can see the Hindu version is the earth on the back of elephants, on the back of a tortoise. And what I find interesting is the tortoise is a whole lot larger than the elephants. I probably would have reversed the order. But basically, it's a snow globe kind of view of the universe. You know, we have this earth, we have this dome where everything appears to be at the same distance, or in the case of, say, ancient Greece, they thought there were different, maybe different domes, one for each planet, etc., out to the fixed stars. But it was a very Truman Show kind of view of the universe, and you know how that turned out. So in 1755, Immanuel Kant starts speculating, and he was not the first person to think of the idea that the Milky Way is not the only galaxy, but he was the one who probably popularized the idea best. And he also was the first one to propose that the solar system was born from a spinning disk of stuff. That's not what he called it, but just stuff. And this informed some of the early telescopic observers who started to see a spiral in some of the galaxies. Earl of Parsons in Ireland, with his big 72-inch telescope, drew out a spiral, which I'll show you in a minute, his sketch of the Whirlpool galaxy. And at the time, it was thought, well, maybe that's a solar system forming. But then along came Galileo and the telescope revolution. Then came Messier, who was one of the, he didn't find the earliest galaxies separate from the ones that I've listed, but he and his friend Pierre McCain probably discovered the largest number of galaxies in the 1700s as he was creating his Messier catalog. And then, of course, then we get things like Hubble and Keck and some of the even larger telescopes being constructed now, finding, you know, it's not just hundreds of galaxies anymore, it's thousands, millions, and billions. Okay, in 1845, William Parsons, on the left is his sketch of the Whirlpool galaxy, on the right is a photograph, and you can see he's got it pretty well done. In a small telescope, like my 5-inch, you're not going to see the spiral arms. When I get to my 11-inch, I can start to make out the spiral arms. I've observed it in larger telescopes, and it just gets easier and easier and easier. But again, at the time, they were thinking this might be a solar system in forming, not realizing that it really was an external galaxy. This started to change for the better. In 1908, Henrietta Leavitt discovered the reality of how Cepheid variables work. There is a period luminosity relationship, and later they discovered there's more than one type of Cepheid, but initially it was this linear relationship between period and luminosity, and from the luminosity you could then estimate a distance. And one of the interesting things a lot of people don't know is the closest Cepheid variable to Earth is Polaris. It's not a very, it doesn't have a very large variation in brightness, but it's only about 400 some light years away. And by having a standard candle like this, it set the stage for discovering the distance to these spiral nebula, as they were called at the time. Vesto Slipher at Lowell Observatory in Arizona came up with two important things that are related to this. One is discovering the galactic redshift, which is galaxies moving away from us. This was important as part of the basis for what Edwin Hubble did. And he also discovered the rotational spiral galaxies by looking at the Doppler shift differences between, say, the left and right edge of a galaxy, and determined that these things were rotating. And from, as they learned more information, able to figure out how fast or slow they were rotating. Another thing is in 1918, Harlow Shapley figured out that we're not in the center of our galaxy, as everybody had assumed before that. So he had the bright idea to look at where are the globular clusters and how far away are they? And oh, the center of the globular clusters is not centered around Earth. It's centered around this large bulge in the Milky Way. And oh gosh, that must be where the center is. And so that was a nice bit of thinking that he came up with. In 1920, he had what's called the Great Debate with Heber Curtis, and they both got something right and they both got something wrong. Shapley, with his globular cluster work, argued the sun was not at the center of the galaxy, but he assumed the spiral nebula were part of our galaxy, and Heber Curtis argued the opposite. So Curtis thought that the Earth was in the center of the galaxy, but the spiral nebula were outside. Then in 1923 and 24, Edwin Hubble observed Cepheids in several nearby nebula, including Andromeda. And the picture in the lower right, the photographic plate there, if you'll notice near the top, there's an N that's crossed out, and then he writes VAR exclamation point. So Hubble had been studying Andromeda and a few other galaxies, and he had found this varying star, and he thought at first it was a regular novae. In fact, the astronomy professor at Fresno State, Dr. Fred Ringwald, one of his areas of study is recurrent novae. And that's at first what Hubble thought it was, but then he realized that it was actually varying according to a Cepheid pattern, and he realized it was a variable, and he was able to use that to estimate the distance to Andromeda. His first estimate was around 1 million light years, but this was before the discovery of more than one type of Cepheid. And so there's actually a couple of variations of Cepheids. They have slightly different graphs between period and luminosity. And our current distance to Andromeda is somewhere around 2.5 million light years. But just 1 million light years was enough, I think, to convince people that these are not inside our galaxy. So in 25, Hubble announces that they are at great distances and that they are external to the Milky Way. And the minute we move these spiral nebulae out of our galaxy, then we must be a galaxy too. And again, that was another, to us, it seems obvious, but in 1925, that was a radical notion. And this was the moment that we discovered galaxies as galaxies. And we started to have a better understanding that these were not solar systems in formation. These were star cities, just like the Milky Way is a star city or a star country or whatever you want, however you want to characterize it. And then in 1929, Hubble and his assistant Milton Humason, and Milton Humason actually did most of the work on this, not Hubble, but Hubble was the guy with a PhD and Humason was not. They discover the proportionality of galaxy distances and redshift. So we have Vesto Slipher's discovery of redshift. Hubble and Humason discover that distance and redshift are proportional, and therefore, again, another brilliant piece of thinking, that not only is the universe large, it is expanding, kind of like my waistline. But anyway, that's work they came up with. And now we'll switch from the science, that's the basic discovery of our galaxy, to galaxy season. So in the Virgo cluster, up through Ursa Major, there are 32 Messier galaxies. starting with M101 in the south, up to M81, M82 in the north. And when you consider that the Messier catalog is 109 or 110 objects, depending on who you believe about M102, this is almost a third of the Messier catalog is in this region. And of course, Messier was looking at brighter galaxies, not the faint fuzzy stuff. And so we have an opportunity this spring and every spring to really go to town in the Virgo cluster. In addition to these 32 Messier galaxies, there are at least 100 NGC and IC galaxies that are not much fainter. And then there are hundreds and hundreds more that are medium to large aperture scope targets. And then, of course, with the weather getting warmer and drier, again, a great time to go hunt galaxies. And I know when I put observing plans together for myself, the types of objects I look at are partially seasonal, because when I get to March, April, May, it is very galaxy heavy. When I get into, say, September, October, it's not. It's just the different types of objects that you can see different times of the year. So this is the rough distribution of galaxies. This is from Tyrian's Cambridge Star Atlas. And that's a 6th magnitude star atlas. So it really is listing only the brighter galaxies. But these are the biggies, the big areas, the Virgo cluster, M51, the Whirlpool, M101, 81 and 82, and so on. And these are the big targets. Now, from California, we're not going to see the large and small Magellanic Cloud, but the other ones that I've marked and all the ones in between, we can see from here. So the local group, and unfortunately I forgot to put in a picture of this, but the local group has several dozen galaxies, Andromeda and the Milky Way being the two brightest. It's a little bit hard to tell where the edge is, but it's several, I don't know, it's probably about 8 to 10 million light years away is the rough gravitational edge of the local group. And things like Bernard's Galaxy, which is a summertime galaxy, is part of the local group. We also have some nearby groups that we often look at, the M81 group, Maffei Sculptor, M101, et cetera, are groups of galaxies. And around M81, M82, there's more than just the two bright galaxies that are available for small telescopes. The closest large cluster is Virgo, and that, you know, I did the all of the Messier galaxies in Virgo with my 5-inch scope, and you can see them in smaller scopes than that. And then, of course, we have more remote clusters, and the further away you get, the fainter the galaxies get, the larger telescope you need. And so if your funds are unlimited, you can always upgrade. So this is the Messier galaxies within the Virgo cluster. Nice little grouping there. If you look at where M84 and M86 are, off to the left and up is Markarian's chain, which is really fun, just a galaxy hop across that. But there's a lot there to see. And then the brighter NGC galaxies in the same region are shown here. And I've seen most of these. There's probably a few that I've missed, but there's a lot. Don't even have to move your telescope very far. There's a lot in there to see. So there's a lot of different interesting galaxies, and it would have been possible to put in 50 slides of interesting galaxies, but this is one of my favorites. This is Hoag's object. This is a Hubble Space Telescope photograph, and it shows a ring galaxy. And by computer modeling, they've discovered that the way you create a ring galaxy is you have another smaller galaxy interact with this one by doing a bullseye shot right through the middle, coming in basically top down to bottom, going through the galaxy, and the gravitational disruption creates this ring. Eventually, the galaxy will settle back down into something more normal than that. But what's fascinating about this one is just above the center, you'll see a small ring galaxy in the background. And so this is like a 2-for-1 here. This is well beyond my limits to see with my telescopes. I can't remember what the magnitude is, but it's pretty faint. But it's just a gorgeous galaxy. And there's other ring galaxies like this, but this is one of the best because it gives you 2 for 1. We also have a number of interacting galaxies. The Whirlpool again. You have the antenna. Now, the Whirlpool is a great small telescope object, and as the scopes get bigger, the Whirlpool gets better and better. The antenna, I never really saw with my 5 very well, but in my 8 and my 11, it's real easy to see. Obviously, you don't see it like the pictures here. It's much more gray. You're not going to see color with typical amateur scopes, but it's really pretty to be able to see 2 galaxies hanging out next to each other and knowing that they're doing this kind of cosmic dance with each other. Now, just a few of the observing challenges that and there are lots more than this, but in small telescopes, I would say the bridge in M51 between the main galaxy and the satellite galaxy, dust lanes in M31 and M104. In medium telescopes, I'd say Stephan's quintet is good. In my 8-inch, I can see on a good but not outstanding night in the mountains, I can see 2 of the 5 galaxies in Stephan's quintet. In my 11, I can see 4 of them. I should be able to see the 5th, but I've never quite had the pristine skies since I got my 11 to see that. Another fun thing to do is track down the NGC objects in M31, M33, M101. These are faint, brighter areas that have NGC listings. And it gets a little challenging because you have to find a good finder chart for the NGC objects within the galaxy. And then it's a combination of star hopping and teasing out the bright areas. Another one is supernovae. The first one I saw was in something called the Fireworks Galaxy, which I think has hosted something like 8 supernovae in the last 100-some years. And a couple of years ago, I was up in the mountains with our club, and one of the guys mentioned that a supernova had gone off a couple days before in the Fireworks Galaxy. And so I keyed in the NGC number to it, and sure enough, there was this 13th magnitude star that was the supernova. If you have a large telescope, one of the best challenges is to see the jet, the relativistic jet in M87. My understanding is the smallest scope it's been seen in is around a 20-inch. I've read several reports on the internet of people seeing it in larger scopes, and once they've been able to figure it out, then they can go back to a slightly smaller large scope and pick it out. I read one report where somebody saw it in a 48-inch amateur scope and then went back to his 30-inch scope and was able to see it. And there's lots of other observing challenges. And one of the things I like to do when I go out observing is, there's a lot of things I like to look at every time that I'm out if it's up. M13, if it's up, I'll look at it. But I also like to find things that are challenges, things that stretch my poor eyes to work better, my brain and eyes to work better together. And so I've done things like I've been hunting down asteroids is one thing. If I get a good night, and Stephan's quintet is more of a late summer, early fall object. I'm going to see if I can find a really good site, really good skies, and look for that 5th galaxy. I've seen 2 of the 5 bright moons of Uranus with my 11. The guy next to me had a 20, and I saw 4 of the 5 bright galaxies. So those are the kind of things that I like to do to challenge myself. So depending on the type of telescope, size of telescope you have, you may identify some observing challenges, dust lanes. They're very sensitive to the sky, and so you need a really good sky to see the dust lanes in M31 or M104. But it's a fun thing to do, is to challenge yourself and not just keep looking only at the same thing each and every time. So that is the end of Galaxy Quest. And I think we found our last galaxy. So if anybody had any questions, be willing to entertain those. Let me.
Excellent. Thank you,
Gary.
Fred. Very interesting. Great great photographs and slides.
Thank you.
Okay, let's stump Fred with our galaxy questions again.
Fred, this is Paul Kovacic.
Yes.
I was wondering, you had small, medium, large telescopes. Could you give me a range of what each would entail?
Yeah, it kind of varies by person, but to me, a small telescope is like a 6 or smaller. A
Okay.
medium is going to be maybe 8 to 12, and a large scope would be, say 14, 16 and above.
Okay.
In our club, the largest anybody has ever owned that I'm aware of is a 30, but he was somewhat infirm, so he never brought it to a star party. The biggest that's come to our star parties is 25. But most of the people, I mean, the single most common size I see everywhere is an 8-inch.
Okay.
It seems like everybody has either an 8-inch Dob or an 8-inch Schmidt-Cassegrain. That's the most common stuff that I see. And so a lot of times when I do talks, is I try to orient it, when I'm talking to other astronomers, orient it more towards the 8-inch size. A couple of years ago, I was up at the Sequoia Dark Sky Festival, and that's actually hosted the National Park Service and the Kern Astronomical Society. And we went up and hung out with the Kern Club during their Saturday night star party. And I was talking to one of their guys that I had met earlier, and he said that his wife had allowed him to buy an 18-inch because he really wanted to see galaxies better. He had started with an 8. And I told him the reason I bought the 11 is I didn't want to have a scope that big, and my goal was to see globular clusters better. And for me, the 8-inch only resolves, maybe a half dozen globular clusters all the way across, whereas the 11 is probably about 30. And the 11 allows me to routinely see May-L2 in the Andromeda Galaxy. With my 8, I saw it once after many, many times trying. But I had perfect skies and so on. So it really depends. And I would think your club's no different than ours. You probably have a large population of 8-inch scopes, but those are still big enough to see pretty deep and to see some of these challenge objects.
Thank you.
You're welcome.
Hey, Fred, this is Jeff Baldwin here.
Yes.
That 30-inch scope down in Fresno, one of our members bought that.
Oh, we did. Okay.
It was a 30-inch F5, right?
I never saw the scope. The guy who owned it was I think he was an attorney and was near retirement age. And but he got to where he couldn't really move it around, so he just left it at his. He lived out in the country somewhere. And but yeah, it apparently from people who had gone over there to look through it, it was a really nice scope, which I would expect for a 30-inch.
Yeah, Brett Ford bought that after his 20-inch Obsession got stolen.
Okay. Yeah, sorry to hear about stolen scopes, but that does happen.
Yep. Hey, Fred,
Yes.
you talked about Immanuel Kant coming up with the idea of we weren't the only galaxy. Do you know if he had seen Rossi's pictures or drawings of 51, or had heard of it, or?
My understanding is those drawings were fairly prevalent in the astronomy community, but because it's essentially a pencil sketch, and there was already this idea that solar systems might form out of a spiral. That was the first thing people thought of. One of the things that has happened all throughout history is that if people have a preconceived notion, it's really hard to get them off of it.
Yeah.
And it's that way for us today. I mean, we all have our preconceived notions that somebody really ought to hit us upside the head with a 2x4 and straighten us out, but we'd have to do it for each other.
Well, Immanuel Kant really did think outside the box in a lot of different ways.
Yes, yeah, he really did. He and when you look at the history of science, it is people running counter to the prevailing idea.
Right.
A really good example is Einstein with relativity. There was absolutely nothing wrong with Newton's physics until there was something wrong with it. And Einstein was the guy that figured out, oh, here's how it works. And of course, he built on Maxwell and a few other people. But it's the preconceived notion is the first thing you think about because nobody else had thought of something else. But the idea of external galaxies had appeared to other people. And in fact, if you go back to ancient Greece, and I can't remember who it was, that one of the ancient Greek astronomers thought that there must be other planets out there with other civilizations, when he had zero evidence for that. You know, no telescopes, no nothing. And he was already thinking, this might happen.
There was an Italian priest in the 1600s that got burned at the stake for coming up with that.
Yes, yeah, that was Bruno.
Yeah.
Yeah. But that idea actually goes back at least to ancient Greece, and who knows if it may have gone back to ancient Babylon, for instance.
Yeah.
We don't know.
Hey guys, Mike says his name wasn't Bruno, it was Berno.
Oh, Bruno? Yeah.
Joke.
It's a joke.
Okay.
Bad humor. Sorry.
Sorry, I'll shut up now.
I'm a little slow on the uptake.
Okay, other questions or comments for Fred? Hey, Fred, I've got one.
Yeah.
So you explained that before Hubble, they used to always think that galaxies were nebulas, but Hubble was able to distinguish them as galaxies because his discovery of his use of Cepheid variables as a standard candle established the distance of Andromeda.
Yeah, and actually it's an evolving thing, because with large telescopes, they could see stars in these other nebulae, but nobody had made the leap yet to, oh my God, this thing is so far away, it has to be external. And that was, again, it seems very simple to us today, but somebody had to come up with that idea, and that was Hubble.
Okay. And then my other question is, Fred, in observing galaxies, techniques and tricks, filters, averted vision, tell us some of the insight.
Okay. Filters generally don't work with galaxies because, like with a nebula, if you're using an oxygen-3 filter or a nebula filter, you're isolating a certain wavelength of light. And galaxies in general are this just kind of homogeneous thing. I understand with some galaxies, if they have a very, very large star forming region, such as the Large Magellanic Cloud with the Tarantula Nebula, and there's a couple of other galaxies where this has worked, where you can put a nebula filter on it and enhance the view, but in general, no filter. Averted vision is very important. There's also some breathing techniques that if you read some of Stephen James O'Meara's books, he has one on the Messier catalog, one on the Caldwell catalog, etc. And I think it's in the Messier book where he talks about essentially deep breathing to put more oxygen into your brain. I've never had that succeed for me, which means I'm probably breathing wrong. But averted vision is very helpful. And one of the things, again, that O'Meara talks about is figuring out where on your eye your most sensitive vision is, because it does vary person to person. And so he's gone to the trouble of using averted vision in different directions to figure out what angle he turns his eye to get the brightest view. I'm too lazy to do that, so I haven't tried it, but I have used averted vision to probably get another magnitude at least. But there's one other thing. I did this years ago. When I bought my 5-inch telescope, it came with a cheap Celestron prism diagonal. And I used that for about a year. And it gave nice views on bright objects, but I felt like I was probably losing too much light. And so I bought a Teleview, 1.25" Teleview diagonal, like 98% reflectance and the whole thing. And just with that change, I gained over a magnitude on stars. Just with that change.
I found the same thing when I upgraded my star diagonal.
It made a huge difference, especially when you're starting with a small telescope.
Yep.
It was just phenomenal. And so all the diagonals that I have now for my 8 and my 11 are all high quality mirror diagonals. Yep. Because you want to eke out the most light that you want to get the light on your eye, not on the equipment in between. Another thing that is helpful to do, I don't do this very often, but some people do it, is if you're having trouble spotting a galaxy, get your telescope near it and shut off the drive motor and let it move into place if you position it right, and your eye may pick up the change in brightness. Another thing you can do is wrap your tube, shake it a little bit. And that's actually how I found Omega Centauri for the first time. From Fresno, it rises maximum about 5 degrees above the horizon. And the site we were using at the time, Fresno was due south of it. So we had this brilliant light dome right where Omega Centauri was going to peak. And I could follow all the stars down to where it ought to be. And I knew where it should be, and I couldn't see it. So I started wrapping the telescope, and I saw this, call it a 101% on 100% bright background. But by tapping the scope, I could see this little bright thing move back and forth. And then I went and star hopped back to it again, found it in the same place. And then I put binoculars on it, and there it was. Again, barely, but I was able to see it. And the funny thing was, I'd only been in the club about a year. And so when I announced it at the star party, all the old timers were saying, "You can't see that from here." And I said, "Sure you can." And I had them come over to my scope, and I wrapped the scope. "Oh my God, there it is." So then everybody goes and points their scopes at it. And I had the smallest scope there. But that was one of my first observing challenges. I've seen it better by going a little bit further south into a darker sky. The best I ever saw it was at the visitor center of Mauna Kea. And at night, the docents bring out some telescopes, and they brought out a 16-inch Meade. And I was able to see it through that. And it was, 25 degrees above the horizon, 30 degrees above the horizon, something like that, and just full of stars. But yeah, there's observing tricks like that you can do. For some people, it's getting LASIK. For me, a little over a year ago, I had to get cataract surgery on my one good eye. I had about 6 months there where I couldn't really use a telescope very well because my vision was getting cloudy, but they won't perform cataract surgery until it gets to a certain point. And so I got cataract surgery a year ago last December, and all of a sudden my vision improved to like I was when I was about 30. So anyway, those are some of the ideas. There's probably others too, but those are some of the things that I do to try to tease out the faint stuff.
Excellent. Thank you for those tips and tricks. I'm going to try some of those. So next time I view through one of you folks' telescope and I start shaking it, you know what's going on, okay?
Yeah. Yeah, you just wrap the tube a little bit, and that's enough sometimes to bring out something faint. And once you've seen it, then it's easier to see it when the scope is still, because your brain now has a better clue of where it's looking.
It's trained on it, huh?
Yeah, it's trained on it.
Yeah.
Add a mallet to your toolbox.
Yeah. 5-pound sledge works pretty good too.
And is it true that almost all galaxies have black holes?
Most of them. M33, we have not found one, but it's a smaller galaxy. It's maybe 10, or it's about 20% the mass of the Milky Way, and we have not found one there. But some of Andromeda's satellite galaxies, the small spheroidals, may or may not have, depending on which galaxy. But all the big spirals that we found, and all the big, like M87 with the jet, I mean, that's one of the largest black holes we know of in the ellipticals. But yeah, most of them do. My guess is something like M33, if it has one, it's going to be pretty tiny. Pocket-sized black hole.
Hey, Fred, I just wanted to say, very nice job on the graphics and the look of your
Thank you.
presentation. It was very well done.
Thank you.
Yeah, that was great. Okay, well,
let's give him a hand. Huh?
Wrap it up. Thank you, Fred.
You're welcome. And I've already told Tim that if you get a hole in your schedule later on in the year, I've got some other stuff I can do too. So
fantastic.
We'll look forward to that. Okay, Mike, hey, back to you.
All right. Okay. Jeff has an announcement or two. So why don't you go ahead and
or maybe four. All right, so the big one is the winner of this week's or this month's random selection. And Mike got a $400 card to Home Depot for the winner here. It's a $10 Starbucks card.
Hey.
Tough.
Still awesome. Anyway, congratulations, Maria Garza. I think this is.
Hey, Maria.
That woke her up.
Didn't you have one before?
Thank you. Thank you. No, I have not won before.
Oh, well, congratulations.
First time.
You've got my email. You've got my email, Maria.
Yeah.
Go ahead and send me an email and give me your snail mail address and I'll mail it to you.
Alrighty. Alrighty. All right.
Awesome. Congratulations. Okay, the next announcement is there is an ATM, first official ATM we've had in a long time, amateur telescope making, and it'll be in my shop on Saturday the 24th from 10 a.m. to 2 p.m. The next one is Saturday night is our high altitude star party schedule, and we can go to the heliport or we can go to Peddler Hill. I haven't looked at our snow cam yet, but I got a feeling Peddler Hill might be clear.
Let us know what it's going to be.
Saturday night.
Yeah, the heliport or the other place.
Don't know yet.
Oh, I'm not sure yet. What I'll do is I'm going to check the snow cam that Eric hooked us up to. And if I can't see any snow at 7,000, we might as well go for the glory and head up to Peddler. When Mike and I figure out our plans, we'll post it on our bulletin board and let everybody know where we're going. Do you know why I wrote that?
I had actually looked at the cam. I looked at the cam about a week ago, and there was still snow on the ground. So,
okay, well, we could play it safe and go to the heliport, but what I'll probably do is check a few things, and then some people might go up high, some people might go down low. We'll see. Anyway, Saturday night. That was it, Mike.
Okay. Any new business from any of the members? Anything you want to talk about? Pretty much.
Was Nihar going to give any kind of report?
I don't know. Is Nihar here?
Yeah.
Well, let's ask Nihar.
Yeah, no, I wasn't giving any report.
Okay. How about Gettysburg Address? Sorry, I won't ask you to do that. All right. So, yeah, right. Thank you, Jeff. I appreciate that. I can't think of anything else. If anyone else has a point to bring up or interesting news or questions about what's going on in the club, if not, I'm going to adjourn the meeting. Okay, motion to adjourn.
So moved.
Okay.
Bye, everyone.
Second.
Take care, everybody.
All right.
Thank you
all
very
very
much, Fred. Great job.
Hey,
Thank you.
Thank you.
Yeah.
You're welcome.
Nice
Thank you,
lecture.
Debbie, for
Thank
sharing your
you.
computer.
Right,
Yeah.
everybody.
Bye.
Thanks a lot.
Bye, Olivia.
Definitely wiggle your scope.
Bye.
Bye-bye.
Beautiful.
Hey, Bob, how you doing?